Hello, hello, good morning to you. It's a beautiful morning here in Woodstock, Georgia. Tell you what. All right, so today we are going to do the product and quotient rules. And we've already seen that the derivative of a sum of functions is just the sum of the derivatives of the functions. So something like if I added f plus g and I wanted to take the derivatives, then I just take the derivative of f and then take the derivative of g and add those together. Now this is not true for the product rule, or the product of two functions. So here's the product rule. If I have f of x times g of x, and I'm going to differentiate this, then basically I need to take the derivative of the first one, multiply it by the second function, and don't change the second function. So multiply it by the derivative of f times g plus the derivative of g times f. Now, in order to memorize this, we can just do fig plus gif. All right, so fig plus gif, that'll do it for you. Okay, so the first example that we'll do, it says x to the third power. Let me see if this is going to read my pen now. Okay, so I'm going to underline the first thing that we're multiplying. This is called a factor, right? And then I'm also going to underline the second one. Maybe that'll be with a single stroke there. All right, so I have two functions, f and g. So this formula tells me that I need to take the derivative of x to the third, so that'll be 3x squared. But then I just need to write down the function g, and the function is sine x. I need to join that with a plus sign, so let's find a neutral color like a blue. And then we're going to do g prime. Well, g prime, well, that'd be the derivative of sine. Well, the derivative of sine is cosine x. And then we just need to write down what f is. And I can write that down. I can write that down in the front if I want to. Okay? And it probably looks better that way, right? So there you have it. That is the product rule in one of our problems. Okay, so what we're going to do next is we'll do the product rule, but it just has this different notation, Leibniz notation. Doesn't change the problem any, okay? So we're going to do the same product rule. So there's x squared, that's the first function, and cosine x will be our second function. So we're going to be taking the derivative of the first function, will be 2x. We will be multiplying it by the second function, so just cosine x. We don't have to change that at all. Plus sign. Then we're going to come back and take the, rewrite x squared. And then we're going to take the derivative of cosine x. Now remember, with the derivative of cosine x, it's negative sine x. So just rewriting some terms here in the next statement. Maybe I can write it as 2x cosine x. Actually, maybe we're just rearranging some factors, right? So this is negative sine x, so I could just write this as minus x squared sine x. Okay? Because minus sine x is like negative 1 times sine x. And I'm just going to multiply that negative 1 by the 1 in front here. And that just makes this a negative sign. So anyway, that is the second example on how to do the product rule. It may or may not seem to be more challenging than that. We have, in this case, in both cases, we have a power function times a trig function. Now sometimes you can have a power times an exponential, or a power times a natural log, but the product rule itself will not change. Okay, so you'll just have to use the appropriate rule for whichever type of problem you have. The quotient rule is another rule that that you'll have to be familiar with the next time you take derivatives, let's say in the homework, right? So the reason I like remembering the product rule in this order, fig, gif, is because basically the quotient rule is almost the same thing. You can memorize it as fig minus gif over g squared. Okay, so not too hard to remember. If you remember, the first one is fig plus gif. The quotient rule will be fig minus gif over g squared. Notice that the quotient of a derivative is not the derivative of a quotient like this is not the quotient of the derivatives. It's something, you have to use this formula. Now, you can remember it this way, and this is the way it was taught to me. You can call the top one the high and the bottom one the low, and it would be low d high minus high d low over low low. So that's basically low. Low would be g. D high means derivative of the top one. High, that's f. D low would be derivative of g. Now if you just rearrange this, it looks like fig gif. Okay? And low low would be g times g, or g squared. Right? So so that's just a fun way to memorize it if you want that fun way to do that. Okay, so we're going to use the product rule on f on this first example. So if I'm obeying fig minus gif, that means take the, and this is going to be, this is already called f, so it's not appropriate for me to call this f over g. So maybe I could rename this one as maybe an h or something like that, just so I can kind of use the formula that I've given you. So the derivative of the top then, that would be 7, and then we just write down the 5x plus 2 minus, and we take the derivative of the denominator, and that would be 5, and then we have 7x minus 3. And that'll all be over 5x plus 2 squared. Okay? With some distribution and simplifying up top, it gives us 35x plus 14 minus 35x plus 15. And what you'll see there is that the linear terms will cancel out. The 35x minus the 35x. And then the 14 plus 15 will give us 19. Okay? And we can leave our answer just like that. You don't have to FOIL the bottom. Actually, I encourage you not to FOIL the denominator. Okay, so leave it just like that and we'll be happy. So that was two linear pieces, or a power function divided by a power function. So what if we had something like a trig function divided by a power function? Well, the rule's not going to change, okay? So the rule's not going to change. You just need to make sure that you take the derivative of whatever piece it is correctly. So what we're going to do is we'll take the derivative of sine, it'll be cosine, and then we're going to write down x cubed. I like to write that in the front, as do most people. Okay? So the next part, we're going to do gif. So that means that we're going to be taking the derivative of x to the third, and that'll be 3x squared. We'll write down sine x, and then we will square x to the third. Well, if you take x to the third and you square it, that's a power to a power, so that'll be multiplying. Okay? So that'll be x to the 6th power. What you'll probably want to do is, you see that you have x to the 6th down here in the denominator, and you have x to the third and x squared. So in the numerator, you have x squared in common. So you can kind of take a greatest common factor out and call it the remainder x cosine x minus 3 sine x. And that's all over x to the 6th power. Well, now we can divide these two factors because they're joined by multiplication. We can divide those. So x squared will cancel out entirely with x to the 6th, but x to the 6th becomes x to the 4th power. All right, and that is actually your final answer. So as a student, you'll probably just rewrite this so that whoever's reading your page will have a nice answer to look at. So there you go. That is how we would find dy dx if we have a trig function on top and a power function in the denominator. Now the rule is, you can see all kinds of rules come into play. Just dropped my pen. You can see all kinds of rules come into play, but the product rule is not going to. I'm sorry. What I mean is, you can see all kinds of functions come into play, but the product rule itself is not going to change, and neither is the quotient rule. Neither is the product rule. So I've done my best today to teach you how to do the product and quotient rules. So hopefully at this point in time you are ready to do a little bit of practice. So good luck. I will let you know that at the top of the screen now we'll show a card, and that card kind of links you to the next video in the series, and also give this thing a thumbs up so that other people can see the lessons. So make it blue, make it gray, whatever color it's supposed to turn, right? All right, see ya.